Good morning and welcome to this session here about improving the energy efficiency of a light commercial application. My name is Jörg Saar, and as you can see from my polo shirt here, I'm from Danfoss. Yeah, energy efficiency and improving the energy efficiency. Before we talk about that, I would like to give you some information about eco-design guidelines. Because these eco-design guidelines, they are there to show that you need to do something on your application. You need to make that application more energy efficient. And how an eco-design guideline works, I would like to show you that here on a pretty well-known one, light bulbs. That's pretty old, but you all know that. Let me click through this here, and then you can see it all. You probably all know we had these old light bulbs, and they were replaced again and again by different light bulbs, and now we are back to LED lights here. But in between there were some others. And the motivation of a guideline is always mentioned in the guideline. It is to decrease the energy consumption, and it has a certain target here to get down to a certain energy consumption. For some of these guidelines, there is a minimum standard where it just says you have to reach a certain efficiency or you're not able to sell. And for some of these guidelines, you have a labeling like this one here, which then tells you where are you on the label. And that's for any eco-design guideline in Europe, no matter what we talk about. That's the general principle of an eco-design guideline. It says what it's relevant for. It wants to decrease the energy demand for that application. And it states a target where we want to end up in the end. That's the same for a commercial refrigerator. Not the same numbers, of course, but it's the same principle. So there is a principle, there is an eco-design guideline which says, well, you have to label your commercial refrigerator, and depending on the energy efficiency of your refrigerator, you have to put that label here, and then you are in one of these classes. The picture you can see here is a commercial refrigerator, and there are several things you can do to have a higher energy efficiency. You can work on the insulation, you can have better ceilings around here, but that's not where Danfoss can help. Danfoss can help on the refrigeration circuit. So compressors, heat exchangers, expansion valve, maybe controls. And if we go a little bit deeper into that, that's what you see here. So you see a compressor, you see two heat exchangers, condenser and evaporator, an expansion valve, and a controller for the unit. So that's what you can work on to make your unit more efficient, as well as insulation and so on. But I want to focus on this one here. The customer approached Danfoss, and that's an example you see here, and said, well, can you help me to do that unit more energy efficient? To do that, just a short information, Danfoss has so-called application development centers, where we can bring in units from customers, do tests on these units, and then replace components, do new tests, and help the customer to make that unit better and more energy efficient. This test that you see here, that has been performed in Norborg, which is in Denmark, and at the headquarters, and each of these application development centers can do different tasks and has different possibilities. What you see here is what that in Denmark can do. That's where this unit has been tested. And here are the test results. Well, you don't see anything because I would like to give you one further information. There is a test standard, an EN standard, EN 16825. And that test standard is relevant for commercial refrigerators and freezers. And that test standard gives you a certain test condition for one condition, 25 Celsius, ambient temperature, 60% relative humidity. At this condition, you have to test your commercial refrigerator and freezer. And that's what we did. And we just took the freezer or that refrigerator as it came from the customer, and we did a baseline test. So that is the baseline test. That's the energy consumption of that unit over 24 hours. That system had a capillary tube. So the first thing we did is replace the capillary tube with an expansion valve. What do you expect? Any idea? Whatever you think, some people might say, well, probably nothing. You're right. if you replace that capillary tube at the specific test condition with a thermostatic expansion valve, if the capillary tube is selected in a good way, you don't get anything because it's on one operating condition and it's optimized for that operating condition. So it can be an optimal expansion device for that operating condition. So you don't make anything better. What you can do, however, is to replace the refrigerant. That unit had 404A, and we replaced that with R290. And R290 can give you a higher efficiency, and that's where you all, oh, whoa, 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 now I've been too fast. Yeah, now you've seen a lot of things already. And that's where you can see 11% increase just by changing the refrigerant. The next step was then, and that's what you can see here as well, there was not a big improvement going from the existing condenser, which was a fin and tube, to a microchannel. So that condenser was really good for that unit, and we couldn't do anything better on that. Then there was a big step, and that's the compressor. The standard unit, the baseline, had a fixed speed compressor. This one is a variable speed compressor, but running on fixed speed. Now you wonder, where is that improvement coming from? Well, pretty simple. These variable speed compressors, they typically have more efficient electric motors and are built in a way that they run more efficient. And that's where the improvement comes from. And if you would then even go to variable speed, that might even be better. But that's where you end up. So you get a lot from that compressor, even if you run it on fixed speed. Well, and then finally, that unit had electric defrost. You can change that to hot gas defrost. And then you save some energy because you don't do electric defrost. You use the hot gas you have already available from the compressor, and that gives you an additional saving. So in total, 47% savings compared to baseline. That's according to test standard. Now let me jump a little bit into reality, especially when we talk about the expansion device. Because that test standard, that tells you have to test that at one condition. That's this one here. That's the test standard condition. 60 Celsius, 60% relative humidity, 25 Celsius. But that's not where every unit runs. So it might be colder around the unit, might be standing in a colder area or in a warmer area. And that's what we just tested. We said, okay, let's make that warmer at 40 Celsius and 40% relative humidity, and let's make it colder. And that's where you can see differences already between capillary tube and thermostatic expansion valve. Simply because now, for these conditions, the capillary tube is no longer the best choice because it has been optimized for exactly this condition and not for those. So the further you go away in real operation from the test point, then you have possibilities to make that unit more efficient in real life. But you will not reflect that on the label because the label is according to this one. That was just a side information. So as a short summary, you can replace different components, but it depends on which component you use and where you had an optimization point already on your existing unit. It does not mean that just replacing a component, you always get a higher efficiency. It depends on what you do, but in a combination, even on the test standard point, you can get an interesting efficiency improvement. If you go away from the test standard point, that might be even additional energy savings in real life. So here on that unit that has been tested, that came really in as a G unit. When we did the calculation, the baseline was a G unit. And with all these changes you've seen, it was possible to bring that unit up to C. Please have in mind, no change of insulation, no change of door ceilings, no change of lights, no change of the fan inside the unit. So if you want to increase that unit even more, you can work on that. But that step from G to C was possible just by replacing those components you have seen. That was it from my side. So you have a little bit more time now. That was a short one. I hope that was okay for you. If you have any questions, I'm still here, so you can come along and ask. Thank you so much.